In this video, we will discuss about Newton's universal gravitational concept and this concept how to involve in space celestial objects or space travel objects. Okay. So first we have to consider about the two types of masses. Here it's the mass one is m1 and here it is the another particle mass it will be having as m2. The distance between the two masses is r. In every object it's having the forces. Here is a f1 and here is a f2 of the forces. So the direction also here. So the mass m1 is pertaining to the object 1 and mass m2 is pertaining to the object 2 and distance of the two masses is r. We know that from the Newton's law F is equivalent to m1 m2 by r square. So it is proportional to the F is proportional to the product of two masses and inversely proportional to the square of its distance between the two masses. This equation will show about this principle. Yes. Next, in this proportional we converted into equivalent. It will be having the one constant is g m1 m2 by r square. So this proportional constant is equivalent to equal. So this is the Newton's universal law with respect to the force, and here the g is the universal gravitational. Here is the g is the universal gravitational constant. Yes. Then the next is we have to focus upon gravity. Gravity. It is indicated up to g. So this universal gravitational constant is with respect to the g. We will having the gravity value g is equal to 9.8 Newton meter power minus 2. So is Newton's gravitational concept, it is conversing or it is focusing upon the two objects or two celestial bodies with respect to their particular mass. So in this oriented, the analytical or problematic questions will rise about the m1 it will be having the 10 kg and for m2 it is having the another 12 kg. The distance between the two masses it will be having it is a 20 meter for assuming. The forces is the both forces are equivalent is 1 Newton. So then how to calculate the g of the universal gas constant? From this equation we can substitute this the Newton is a 1 is equal to g into the first mass is 10 and the second mass it will be having the 12 and divided by the radius is 20. We can substitute is g into 120 divided by 20 is equal to 1. Therefore 1 is equal to 12g. Therefore g is equal to 1 by 12th of this. So this is the way of the method to find the universal gravitational concept from the Newton's law of for the space. And for intermolecular that in case in the problem the universal gravitational concept g is given and the in two both masses the one masses is also given, then we have to find the another secondary mass from the same concept also. So this is the application oriented of Newton's gravitational constant with consider or with respect to the gravity of the earth surfaces. Thank you.